We're going to start, we're going to solve rational and polynomial inequalities. We actually have seen this before. I'm not sure which section it was, but it's a whole chapter or a whole section in chapter 3 now. So we'll do a few problems. We'll start with problem number 8, a polynomial inequality. And the flow of these things is going to be similar to the flow that we're going to use to solve our rational inequalities. I got a little bit of a handout on rational inequalities. You should have a copy of it on your desk. If not, just come on up and grab one. 8 looks like this. 2x squared minus 18x is less than... Was it cubed? Oh, was it cubed? Oh. Okay, cool. Cubed. Thank you. So let me make that a cubed. Is less than x squared minus 9. Alright, so 2x cubed. Let me make that look a little bit more reasonable. 2x cubed. The first thing to do on these types of problems is to get 0 on one side. I guess I want to keep this leading coefficient positive. So I'll move everything to the left-hand side. So subtract x squared and add 9 to both sides. Subtract x squared, add 9. So it gives me 2x cubed minus x squared minus 18x plus 9 is less than 0. Now I need to find where this is actually equal to 0. Well, good news for us, we have a lot of tools that we can use to try and find where it equals 0. You could use the rational root theorem, or you could try factoring it, or let's see, factoring it actually might work. Let's take a look at factoring it. We're trying to find where 2x cubed minus x squared minus 18x plus 9 equals 0. Now, one thing that you can try when you have 4 terms is to factor by grouping. So let's just look at those first 2 terms. Is there anything I can factor out of those first 2? Yeah, factor out an x squared. So if I factor out an x squared, that's going to leave behind 2x minus 1. Now let's see what we can factor out of the second one. Let's factor out a 9. In fact, let's factor out a negative 9, because the negative 9 will change the sign on both of these terms and also leave behind a 2x minus 1. Okay, looking better. You should notice that these 2 terms match. So that's a greatest common factor. I can factor that out. 2x minus 1 times x squared minus 9. And overall, 2x minus 9 times x minus 3 times x plus 3. So now that it's fully factored, you can just read off the roots here. Let's start with the easy 2. 3 and negative 3. How about this one? What root does that correspond to? 1/2. Good. So x equals 1/2. Now that's where the graph crosses the x-axis. We're not interested in just where it crosses the x-axis. We want to know where the graph is below the x-axis. So let's start by putting out those numbers on a number line. So I've got numbers at negative 3, 1/2, and 3. Those numbers break up the number line into intervals. So those intervals would be negative infinity to negative 3, negative 3 to 1/2, 1/2 to 3, and 3 to positive infinity. Your answer is going to be one or more of those intervals. We just kind of have to figure out which. So how do we figure out which? Well, there's a couple ways you could do that, but what I suggest, particularly for these, is that we just test points. So need points inside of each of these intervals. So, Keegan, what would be some points in each of these intervals, please? -4. 0 is my favorite test point. Good. Keep going.
1 and 4.
Nice. So we need to test those, but where are we going to test it? We're going to test it in the polynomial that we got that put 0 on one side. So we're going to go all the way back up here and test those points in here. Now, it's easy to test 0, but we need to test a little bit more than 0. So I'm going to take and enter that into my calculator. So y equals, and then I want 2x cubed minus x squared minus 18x plus 9. Hopefully you haven't changed the settings on your calculator. You should still have your table set to ask for independent. You can check that by hitting the second key and then the window key to do table set. Make sure that it's set to ask. So go over here with the cursor, press enter on ask, and then you can do a table and fill in the exact values of x that you'd like. So to get to the table, press the second key, then the graph key. That'll take you to the table. Let's use Keegan's values here. We want -4, 0, 1, and 4. And that's the table that I'm getting. What information do you think I want from here? What's the important information? Yeah, where it's positive and where it's negative. So overall, we get something like this. Negative, positive, negative, positive. Which intervals do we want? Do we want the negative intervals or do we want the positive intervals? Well, let's take a look back at our inequality. Do we want this to be positive or is this going to be true when it's negative? It's going to be true when it's negative. When it's less than 0, it'll be true. So let's choose the negative intervals. Our answer overall is going to be -infinity to -3, parentheses, then 1/2 to 3. Now this one was pretty nice in as much as the graph concerned itself with only where this was less than 0. So we didn't have to worry about the endpoints. Had the problem said less than or equal to, we would have had to included these two endpoints. So I'd have used a bracket here and a bracket here and a bracket here. Because that would have been where it actually equals 0. So we could include those points. -infinity is not exactly a point. It's kind of like a notion. So you can't really ever get to -infinity. So that's why we don't really include that as part of an answer with a bracket. There is a point, in a graduate course I took, there was a point where we used a bracket around -infinity and +infinity, but that's a few classes ahead of you. So yeah. For now, just parentheses around -infinity and +infinity. Occasionally, people make a mistake and put a bracket there, and I ignore it. I just let it go. It's not a big thing. Any other questions on problem number 8 there? Looking all right. Does this look familiar? We did this before this semester. A couple nods. Beanie Beanie Beachy, right? All right. In case you haven't read a certain tattoo here, Beanie Beanie Beachy translates to "I came, I saw, I conquered." So pretty cool. Nice little Latin quote. I think Caesar was the one that said that one, at least made it famous. Okay, so let's try another one. Problem number 14. So x to the 4th plus 3x cubed minus 3x squared plus 3x minus 4. And we want to know where that's less than 0. Let's make that less than or equal to 0 just to throw in a little bit of wrinkle. So that, I guess, turns us into problem 14-ish, right? But the last one we kind of got lucky in terms of determining where the function was equal to 0. We were able to factor it pretty quickly. This one I'm not sure we're going to get quite so lucky. So let's approach it a different way. In terms of finding out where it's actually equal to 0, let's just go and graph it. So first thing we need to do is enter that into our graphing calculator. So I want x raised to the 4th plus 3x cubed minus 3x squared plus 3x minus 4. And I'm not sure exactly what to suggest for the range on this thing. So for the window, let's try -6 to 6, and let's go -45 to 10. Let's see what we get in terms of a graph. Pretty good. All right. So where does this graph actually equal 0? Where does it touch the x-axis? What values? 1 and -4. So, okay, 1 and -4 are the roots. And that's it. So, -4 and 1. Those are the only places where this changes signs. So my intervals here are -infinity to -4, -4 to 1, and 1 to infinity. Now I could, if I wanted to, test points. But, you know, I think the window we used gave us a pretty good graph. So maybe we can kind of figure out what the signs are without necessarily testing points. Or maybe we'll go back and test points afterwards. But let's take a look to the left of -4. Is the graph positive or negative to the left of -4? It's positive, right? It's above the x-axis. What's happening between -4 and 1? It's below the x-axis. So do I necessarily really need to test points to determine the signs here? Positive, negative, positive. Are you seeing that when you look at the graph? Is the graph speaking to you in that way? If it's not, then what you could do is test some points. You could test, say, -5, 0, and 2. And you should get the same information. So if I go to my table, if I'm like, you know what, the graph confuses me, I don't like it, that's fine. So let me delete the values. Right here's your delete key next to the second key and the mode key. If I type in the values, I should get the same information. So -5, 0, and 2. Positive, negative, positive. Cool. As far as the answer to this problem is concerned, though, I did change it up a little bit to make it a little bit more interesting and add to the teachable moment. The answers that I want are where it's less than or equal to 0. So that'd be this middle interval, -4 to 1. But because I have a less than or equal to, I can include the endpoints. So -4 and 1 in brackets. That wasn't too bad. How are we looking on 14? Okay? All right. Now these are a couple warm-up problems. Sometimes you're going to get rational inequalities. So such problems on your handout. They're very, very similar to what we dealt with the polynomial inequalities in problem 8 and 14. So this is a rational inequality. Just an inequality that involves a rational function. The first thing you're going to do is get 0 on one side. So that's pretty easy. Just move the 3 to the other side. But then it gets a little difficult. You have to write this as one term. You have to write it as a ratio of one term. So what that means is you need a common denominator. if you think of 3 as being 3 over 1, then the common denominator is 2x minus 1. So I'll multiply this by 2x minus 1 over 2x minus 1. Effectively, this is multiplying by 1. So I'm not changing the value of this. In doing that, if I distribute a negative 3 and collect like terms, what would I get in the numerator of this fraction? Negative 5x plus 7. Thank you. So a lot of extra work here, at least at the start, because you didn't have 0 on one side, and even worse, it wasn't, when you did get 0 on one side, it wasn't written as one expression. So that's something you might have to do, depending on the problem, right at the start, is to write it like this. Now from here, the work starts to take a familiar pattern. We're going to have to find, first of all, where the numerator equals 0. So where does negative 5x plus 7 equal 0? Well, that's when 7 equals 5x. I move that to the other side to make it positive. Divide both sides by 5, and we get x is 7/5. So that's one place. I also need to find where the denominator equals 0. 2x minus 1 equals 0 means x equals 1/2. And I hope you can see that a little bit easier than the first one, maybe. Let's put those two numbers on the number line. We're going to have 1/2 and 7/5. Not necessarily the friendliest numbers. That's okay. This still breaks up our number line into intervals. In fact, 3 intervals: negative infinity to 1/2, 1/2 to 7/5, and 7/5 to infinity. We're going to end up testing again to try and decide what's happening in these intervals. Are they positive? Are they negative? The graph, you've seen the graphs of rational functions before. It's a little bit messier, so I tend not to look at the graph at all. I would just rather do some testing of points. But what function am I going to enter to test points? Which of these expressions do you think I should enter? This one right here. The one where you got 0 on one side and wrote it with one rational expression. Now theoretically it's equivalent to this. You can check by graphing and other ways to make sure that they are equivalent. When you enter this into your calculator, you've got to do one of two things. Either you have to use parentheses around the entire numerator, so negative 5x plus 7 divided by parentheses around the denominator 2x minus 1, or if your calculator is up to date with the latest operating system, you can hit the alpha key and then the y equals key. The first option there gives you the ability to write a fraction. So negative 5x plus 7 over 2x minus 1. So it's up to you which one you prefer. I think this gives you a little bit less chance to make a mistake. Again, that assumes your calculator is up to date. If you've got an 84, you can update the operating system. If you have an 83, it's too old. Okay, so let's test some points. Let me delete the values that are there. What would be some good test points for us here? All right, 0. Now 0's in this interval, right? A 1 and a 2. Sure, so 0, 1, 2. 0, 1, and 2. So I get negative, positive, negative. So when I tested that, I got negative, positive, negative. Okay, not so bad. Which of these intervals do I want? Yeah, I want the positive interval. So the interval that tested true would be that middle interval. So 1/2 to 7/5. But you got to be careful. Which gets brackets, which gets parentheses? Well, let's see here. What's going to happen to this fraction if I put in fact, you know what? Here's a nice way to do it. If you want to do this without actually thinking, all right? Let's put in the endpoints. Now the endpoints would be the 7/5 and the 1/2, right? So let me type in 7 divided by 5. Now as soon as I press the enter key, it's going to turn that fraction into a decimal, 1.4. That's okay. It's still 7/5, and I get 0. Is 0 greater than or equal to 0? Yeah, so no problem there, right? What if I type in a 1 divided by 2? What happens now? Wait a minute. How come it's giving me this? I don't get it. Cooper, what's up?
The denominator can't equal 0.
Oh, yeah. If you remember, where'd that 1/2 come from? That 1/2 came from solving where the denominator was 0. Now, if you put that in there and you get a 0 in the denominator, you shouldn't be surprised, right? We found that. But since you can't divide by 0, we can't use the 1/2 as part of our answer. So what's that mean in terms of the notation around the 1/2? Parentheses. Yes, thank you. So a 1/2 gets a parenthesis and a bracket around the 7/5. You can use the 7/5 because 7/5 makes this thing equal to 0. And 0 is greater than or equal to 0. But you can't have undefined is greater than 0. So, yeah, please.
How do you know what kind of choose again from the positive and negative?
Great question. That relates to the sign of this inequality. If I want something to be greater than 0, then I want the positive intervals. If it was less than 0, then I'd want the negative intervals. So it just all comes down to the direction of that inequality. So in looking at this, if I was writing this as a test question, I'd probably change it a little bit. What I don't like about it is that the answers kind of look like all you did was set the numerator and denominator equal 0. There's a lot more to this problem than just where the numerator and denominator is 0. So kind of a little heads up in that regard. Anything else on this one? Yeah, please, Katie.
Is there ever going to be like an instance where it's, let's say, x squared plus x plus 7 over whatever, and then
I'm not going to give you something that that won't factor nice and easily. I mean, if I gave you a problem like that, then you'd have to pull out the quadratic formula. Actually, x squared plus x plus 7. I don't even think it would touch the x-axis. It would have imaginary roots, so that wouldn't change signs at all. But in any case, I'm going to give you stuff that will factor. Yeah. Okay. Let's do one, maybe two more, depending on you guys. Let's try problem number 20. So 4x squared minus 25 over x squared minus 9 is less than or equal to 0. So this is a friendlier problem. We've already got 0 on one side. We've already got the fraction written. It's just one fraction on the left-hand side, so we're good. We need to figure out where the numerator equals 0 and where the denominator equals 0. So 4x squared minus 25 equals 0. Probably a couple ways to do that. I'll illustrate them both here. So one way to do this is to factor it. That's 2x minus 5 times 2x plus 5 equals 0. It's just the difference of squares. Bless you. What about where the denominator equals 0? Well, x squared minus 9 equals 0. Instead of factoring it, let me remind you that you can use the square root property. Plus or minus the square root of 9 gives you plus or minus 3. We didn't finish over here, though. Where does this actually equal 0? Good. So add 5 to both sides, divide by 2, we get 5 over 2 and negative 5 over 2, if you take the time to solve that one. So it's a total of 4 points. That's going to give us 5 intervals. This is one that I definitely probably shy away from the graph and just work this one based on, what happens when I test some points. So let's put out my points along the interval, or along the real number line. So we'll have points here at negative 3, negative 5 halves, 5 halves, and positive 3. The intervals I get are negative infinity to negative 3, negative 3 to negative 5 halves, negative 5 halves to positive 5 halves, positive 5 halves to 3, and 3 to infinity. I'm not sure I thought this one through when I chose this example, that we'd have 5 intervals. All right. But fortunately, we got some technology. But you're going to have to think a little bit harder on this one than in your normal one. So we need some test points here. I'll put that in a second. Now the first one, that's not so bad. I can just use negative 4. But what point am I going to use for the next interval? Sure, negative 2.75. Just go with a decimal. Keep in mind that this is really negative 2.5. So you can go negative 2.6, negative 2.75. Those are both good. 0 works as a good one here. 2.75, kind of a reflection of what we had over here. And 4. Now where are we going to test those? Well, we're going to test those in the original inequality. We got to enter that function into our calculator. So let me clear out the old ones. Now, as I said a moment ago, you either have to use the fraction key or put parentheses around the numerator and denominator. So sometimes I feel like I can overwhelm you guys with all these little calculator tricks. I try and keep them to the ones that are relevant. But I don't know. Any feedback from you guys on the calculator tricks? You like them? Okay, cool. Cooper?
Can you use -2 as a test point instead of fraction?
Well, negative 2 would actually be in this interval right here. So it wouldn't actually fit between these two. Yeah, you're stuck between negative 3 and negative 2.5. There's no nice integer numbers. So you do have to use a decimal at that point. So let me get rid of these and do our testing of points. Negative 4, negative 2.75. Where else do we do? 0, 2.75, and 4. Now, because of the way I set things up, my calculator is actually giving me fractional answers, but that's okay. It doesn't really matter. What I need is I need to know where it's positive and where it's negative. So let me go back here at negative 4. That's 39 over 7. I don't care that it's 5 point something. All I care about is that it's positive. So let's put a little positive up above here. And then from there, I think it alternates, right? Negative, positive, negative, positive. All right, not a surprising pattern. Typically they do alternate. Now the reason that I put in these intervals as soon as I get them is because a lot of times people in a rush get confused and they start using these to create their intervals. These numbers. Your answer at this point is kind of a no-brainer. Let's see, no, we want the negative intervals, don't we? My bad. All right, so still a no-brainer. The two negative intervals here and here. Which of these endpoints get brackets and which of them get parentheses?
Negative 3's got parentheses, and the 5.5's got brackets.
But isn't the other one wrong?
Well, tell you what, let's test it out. If you've got the function entered into your calculator, type in negative 3. Type in positive 3. Do you think I can use those points? What kind of feedback is your calculator giving you?
It doesn't work.
Yeah, it's giving you negative feedback, right? Negative reinforcement. Like if somebody cuts you off on the freeway and you show them the your number one sign, a little negative reinforcement, right? How about problem or 5 halves? We get a 0. Negative 5 divided by 2. So you get a 0. 0 works because 0 is less than or equal to 0. So we're okay with those. We can use those. So overall, it should be negative 3 to negative 5 halves, bracket, union, 5 halves to 3, bracket. So that should be your final answer. How are we looking on number 20? Want one more or are we good? Cool. All right. For homework, try 3 through 13. Wow. 15 through 27. Boy, that sounds too light. I should go back and take a look at that again. You sure? That works for you? All right.